Assalamualaikum warahmatullahi wabarakatuh. My name is Mohammad Hilmi bin Hussien, number matrix BN27301. I'm from Group 5. Our experiment is experiment shearing force in a beam. This is my team, Abdul, Hariz. Okay, next is contents. First theory, second result, data and observation, and also conclusions. Next is the theory. Beams are one of the most often seen structural components because of the inductive response of the force applied to the horizontal member of a structure beam. When the section is loaded in the vertical direction, it will bend when considering the quantity and kind of stresses of the beam, its length, elasticity, and type of beam. It is important to consider how much bending will occur.
Assalamualaikum warahmatullahi wabarakatuh. My name is Abdul, Hariz bin Abdullah. My nomenclature is BNJ27301. I am from Group 5. Today I will explain about my experiment objective. This is an experiment 3, which is shearing force in a beam. The first objective is to comprehend the action of shear in a beam and measure the shearing force at a normal section of a loaded beam and check its agreement with theory. For the second objective is to conduct the experiment correctly and identify the dependent variable and independent variable, record, tabulate, and analyze from data and also measure the shear force direction. For the third objective is to demonstrate work effectively and cooperate in a group to complete the laboratory task. That's all for me.
Hi, Assalamualaikum. My name is Mohammad bin Hussien, number matrix BN27301. Okay, the equipment that we use to conduct the experiment is first is the ruler, second is the beam, and next is this is the rolling pivot, and then this is the pivot, and this two is thumb screw, and then this is the digital display, digital force display. Okay, and then we use this hanging mesh and the meshes.
Okay, I will continue how to set up this experiment. Okay, firstly, make sure the digital force display is on. Okay, after that, we must carefully zero the force meter using the left hand beam of the experiment. Okay, this is a zero. We must set into a zero for this force. Okay, for the thirdly, we must gently apply the small load with a finger to a center of a beam and release. Okay, I show the example. Okay, next we must put the mesh in the hanging. This is the example how to put.
Okay, next we proceed to the first experiment, and then this is the mesh hanging. This is the 400 gram mesh. So this is the RB and this is the RA. So for the first experiment, we need to put the 400 gram 140 millimeter from RA. So this is the 140 millimeter. We can check with the ruler for jarak to measure the 140 millimeter. So from the From the RA to the last point is 140 millimeter, and then we put the 400 gram to the beam. Okay, then after we put the mesh to the beam, we need to check the force that we get. The shear that we get in digital force display is 1.3 Newton. For the second experiment, we use two weight. For this is the 200 gram mesh, and this is the 400 gram mesh. First, we measure the length for the first mesh, 200 gram. So from the RE, we use the length is 220 millimeter. So this is the 220 millimeter. 220 millimeter, and then we put the mesh. Mesh 1 is here. Okay, next we add the 400 gram from the RE. The length is 260. Okay, so the 260 is here. So we put the 400 gram to the beam. Okay, so then we can get from display force digital, the shear is 2 Newton. That's all for the experiment 2. Okay, next we proceed to the next experiment, which is the figure 3.8. For figure 3.8, we also have two mesh. For the mesh 1 is 500 gram, and the mesh 2 is 400 gram. So for the 500 gram, we put on the beam from RE is 240 millimeter. So this is the 240 millimeter. Then we put the first weight. Okay, so for next we put the second weight, which is 400 gram. 400 millimeter from RE. So 400 millimeter from RE is here. Okay, so we put the mesh to the beam, 400 millimeter, 400 gram. So this is the data that we get from digital force display, which is 2 Newton. Okay, okay, that's all for the experiment. Thank you.
Okay, next we want to find RA and RB. This is the how to find RA and RB. 100. Okay. Like this. Must correctly put in position. Okay. This is a value of RA, which is 4.17 Newton. 5.17 Newton. And this is a value of RB, is negative 1.25 Newton. Next, we find RA and RB for figure 3.7. Put the weight. this is RB. Okay. We want to find RB and RB in figure 3.8. Okay, this is RA and this is RB.
Next is result from the experiment. This is the result and the data for the experiment 1, which is figure 3.6. Experiment shear force value is negative 1.2, and the theoretical shear force we get negative 1.25. For the experiment 2, which is figure 3.7, is the experiment shear force is 1.8, while theoretical shear force we get is 2.6. Next is experiment 3, which is figure 3.8. The experiment shear force that we get is 2.4, and the theoretical shear force we get 2.32. Okay, next is graph data force against shear force. We can see from the graph, the yellow color is experimental shear force, and then the green color is theoretical shear force. Next, the observation. In experiment 1, we found that there is only a small difference between the values of experimental shear force and the theoretical shear force, which is the value of experiment shear force is negative 1.2, while the theoretical is negative 1.25. So next, the experiment 2, we found that there is a biggest difference between the values of experiment shear force and the theoretical shear force. The value of experimental shear force is 1.8 Newton, while theoretical is 2.6 Newton. Next is experiment 3. We found that there is only a small difference, also same like experiment 1. The value of experiment shear force is 2.4 Newton, while theoretical is 2.32. So the difference is small. Next is the conclusion. The purpose of this experiment is to investigate the effect of the different force magnitudes on shear force produced in a beam as a result of the force. We can use the theoretical value to determine the beam from the experiment. We can learn more details about the beam and load based on the graph, and we can also analyze the type of beam and how the beam responds when the load is applied by looking at the shear force diagram. That's all for me. Thank you.